Does interhemispheric competition mediate motion-induced blindness? Brought to you by Amanda Childs and Carrie Munkle. Now we'll look at a transcranial magnetic stimulation study conducted by Agnes P. Funk and John D. Pettigrew in the Vision, Touch, and Hearing Research Center at the School of Biomedical Sciences in the University of Queensland in Brisbane, Australia. It was published in December of 2003. 6 male and 7 female right-handed subjects aged 18 to 55 years and naive to the experimental hypothesis were studied both on the binocular rivalry apparatus already described and on motion-induced blindness. All subjects gave their written informed consent and completed a medical history questionnaire for TMS. The study was approved by the University of Queensland Behavioral and Social Sciences Ethical Review Committee. The experiment involved 3 blocks consisting of 4 trials each, where data were collected for a total of 10 minutes per block. The baseline cycle for each subject was determined in the first block, during which no TMS occurred. The researchers could then anticipate the subject's key press by pre-programming the TMS pulse on the basis of the subject's baseline appearance-disappearance cycle, whose regularity lent itself to this approach. In practice, the pre-programmed TMS pulses occurred at various times just before, precisely at, and just after the phase. In this way, the researchers could test the phase specificity of the TMS, both before and after the phase shift in the subject's perception. For the remaining 2 experimental blocks, TMS was triggered to occur 300 milliseconds before the end of each phase. TMS was semi-randomly delivered to both hemispheres, alternating between the disappearance and reappearance phases. For example, in one block, TMS was delivered during the disappearance phase first to the left hemisphere for 2 trials, then to the right hemisphere. In the next block, the same order of hemisphere stimulation occurred, except that TMS was delivered during the appearance phase. The next 4 slides will show the hemispheric effects of TMS on the duration of the appearance and disappearance phases. The first graph shows the hemispheric difference following TMS of the left hemisphere during the disappearance phase. The graph shows the difference between left and right hemisphere TMS, that is, left disappearance time minus right disappearance time. Thus, a negative value indicates that left hemisphere magnetic stimulation induced a shorter disappearance time compared with right hemisphere stimulation. This graph shows the results for the appearance phase during TMS of the right hemisphere. The graph indicates the hemispheric difference, i.e., the right appearance time minus left appearance time, where a negative value indicates that right hemisphere TMS shortened appearance time to a greater extent than left hemisphere stimulation. Also, you can see that the right hemisphere TMS yielded greater fluctuation in difference scores, resulting in a less consistent effect compared with left magnitude stimulation. Now here are the results. Although TMS was timed to occur 300 milliseconds before the end of the phase switch, in practice the pre-programmed TMS pulses occurred at various times just before, precisely at, and just after the phase switch. As a result, the researchers obtained a spectrum of TMS delivery times. Although this range appears rather wide, from approximately 6 seconds before the switch to 12 seconds after it, the vast majority of trials landed within plus or minus 1.25 seconds of the phase switch. Consequently, the researchers targeted trials within this time range. The graph also shows the larger degree of scatter associated with data for the appearance phase compared with those for the disappearance phase, which parallels the pilot findings of more fluctuation following right hemisphere stimulation. The overall effect of TMS on either phase was disruptive, regardless of the hemisphere stimulated. Thus, whichever phase was targeted by TMS, its duration was shortened, and the subject's perception biased to the opposite phase. Table 1 lists data within the target time range, which was plus or minus 1.25 seconds of the phase switch, without considering the time or hemisphere of TMS delivery. Following TMS, the duration of the appearance phase, called A, compared with the baseline, which is duration with no stimulation, is shortened in 11 of 13 subjects and reduced for the disappearance phase, called D, in 9 of 13 subjects. The target time range, plus or minus 1.25 seconds, was divided into 10 time groups, which are shown in Table 2. The A to D ratio was determined for each TMS trial, and the difference between this ratio and that obtained for the baseline was calculated, yielding the A to D baseline difference. A positive difference would reflect a bias toward the appearance phase, where a negative difference would indicate a disappearance phase bias. The ratio difference obtained following stimulation of both hemispheres was compared over all time groups for each perceptual phase by using linear regression. All factors were significant. The analysis showed that left hemisphere TMS during the disappearance phase had a stronger correlation compared with right hemisphere stimulation. R squared for the left hemisphere was 0.7596, and for the right hemisphere it was 0.3843. The appearance phase showed the opposite hemispheric effect, with right hemisphere TMS having a larger correlation, R squared equals 0.5204, than the left hemisphere stimulation, with R squared equals 0.2164. The final figure, Figure 6, shows a comparison of hemispheric asymmetries observed for each TMS time group during both the disappearance and appearance phase. The y-axis depicts the mean difference between the baseline cycle rate and the A to D ratio. Time group 10 approximates the perceptual switch, and time groups preceding the switch, which are negative values, are contained in the disappearance phase, while those after the switch, which are positive values, are within the appearance phase. Note that the negative and positive values are arbitrarily set and simply provide a means of delineating between the disappearance and appearance phases. The average difference for the disappearance phase was much greater than for appearance. Importantly, the positive increase for the disappearance phase indicates that left hemisphere TMS shortened disappearance and lengthened appearance to a greater degree than right hemisphere TMS. The negative difference for appearance reflects greater shortening of the appearance phase and lengthening of the disappearance following right hemisphere TMS. Now we will discuss the conclusion of this study and how it relates to our study of consciousness.